For the second set of problems, I would like you to try these problems on your own. Stop the video, try it yourself. If you cannot get it to turn green, then come back and watch the video for some extra help and see where you went wrong, see where you kind of went off the right path and whatever. But again, stop the video right now, and then if you get stuck or you don't know what to do or you can't get it to turn green, then come back and watch the rest of the video. All right, given this equation, m is equal to -5 times t plus 300, where t is the time in seconds and m is meters left to travel. An increase of 2 minutes. Well, okay. This is going to be, I think this is a typo here. I'll have to change this at some point. Where this says seconds, we're going to need this to be seconds as well. So we're going to assume that this says 2 seconds. An increase in 2 seconds will lead to a blank of meters. So now, again, if I'm reading this correctly, if I am traveling for any amount of time, I would imagine that my distance is going to go down because, let's say I'm trying to get to Byron, or I'm trying to get to Rochester from Byron. And if I start walking, well, every second that I walk, I'm going to have less distance to go because I'm walking towards Rochester. So I would imagine that as my time increases, my distance, my m, should actually go down. But let's check it out and make sure and see what's going on here, okay? All right, so m is equal to -5 times t plus 300. So let's go ahead and put our t table to work here. All right, so let's start with 0. So if I don't walk at all, -5 times t, -5 times 0 is 0, plus 300. So if I don't walk at all, I'm going to have 300, the full 300 meters to walk, which that makes sense. I didn't walk at all. All right, so now I'm going to go 1 second. So -5 times 1 is -5, plus 300. Well, if I have -5 plus 300, that's like 300 minus 5. So I will have 295 meters to go because this was in meters. All right, so that makes sense. If I walk for 1 second, now instead of 300 meters, I'm going to have 295 meters to go. So that did make sense. As the time is going up, the meters, the distance is actually going down, like we thought. Okay, so now let's go with 2 for our seconds. So we're going to walk now for 2 seconds. All right, 2 times 5 is 10. Now remember, it's negative, so it's -10. So -10 plus 300 is the same as 300 minus 10. So I'll have 290 meters to go. Now let's read this. So we do an increase. It says 2 minutes, but that would be like 120 seconds. We're not going to do that because 120 times 5. Well, it's not going to work out. So this is a typo. So 2 seconds. Is what they want. So an increase of 2, which is what we have here, this is an increase of 2 seconds, results in a decrease in how far? So from 300 to 290, that's a decrease in 10 meters. So hopefully that makes sense, that if you're traveling for 2 seconds, according to this problem, you'll have 10 less meters to go because you're going to travel those 10 meters in those 2 seconds. So you're not going to have to do that again. Like again, if I said, if I'm walking from Byron to Rochester, if I'm walking for 2 seconds, I'm going to have less to go. Now, what's interesting again is if I take this and I go -5 times 2, that will give us the -10 that we're looking for. So again, this is our variable right here, and since we are looking for an increase of 2 minutes, and again, remember, we're going to say 2 seconds, an increase in 2 seconds, so we're just going to plug 2 in there. -5 times 2 is -10, and that ended up being our answer. But the table helps us to see that by plugging numbers in and getting numbers out, and then it helps us analyze what's happening. But our answer is a decrease of 10 meters. So circle decrease and put 10 in here for meters. Okay, so that's how that one goes.